In the last video, I led you through the construction process of the RF section of my RFID tag detector. The LF section will be built up on smaller separate pieces of variable board later. First, I will show you how a casing for the detector can be made. I do this now because the biggest components are ready. I will first see how to build them inside the case, and later on the still to be made circuits will be sized to fit inside the remaining spaces. These biggest components are the board carrying the RF circuit, the meter and the two battery compartments. They all will be attached to this blue aluminum enclosure. The advantage of a metal housing is that it allows proper shielding of the RF circuit. The first step is now to drill a number of holes through the part of the enclosure that will be the front panel of the detector. After taking measurements and punch marking the holes, they are drilled. If the enclosure is made of plastics or aluminum, a brace can be used instead of a power drill. While the holes for the fastening of the battery compartments are mere 3 mm in diameter, the hole for the meter must be much bigger. Here a drill press is coming in handy. A normal handheld power drill, however, will do the job too. After the drilling is done, the edges of the holes must be freed from swarf and the hole for the meter must be filed into the right shape. The battery compartments can now be bolted to the housing. And after deciding not to use any glue, a few more holes must be drilled before the meter can be fastened too. After that, the RF board is bolted to the bottom part of the enclosure. Make sure that the board is not fastened directly onto the metal surface, but that a few millimeters of clearance must be established to prevent the conductive path of the circuit from touching the metal surface of the enclosure. You might have noticed that I temporarily removed the detector coil from the board. This, however, is not necessary. Next, two slits are cut in the upper section of the enclosure. This will allow the connector wires of the detector coil to pass the enclosure, while the front panel will be removable. Last but not least, some more holes need to be drilled for the core of the RF transformer, the potentiometers for nulling the op-amp, and depending on whether you want to use them or not, the indicator LEDs, and of course the power switch. Once these parts are fastened to the front panel, the work on the detector's housing is completed. It is time to add the power supply and voltage reference circuits. For that, I cut out a piece of variable board that fits behind the RF board. I decided to use separate boards for the functional units. This means it is easier to replace parts of the device. This is of importance to me because this is still an experimental prototype that will be improved in the future. A working model could, however, be built with just one single variable board. I decided to use the power supply's voltage regulators also to fasten the second board to the housing. The housing will thus work as a support and a heatsink at the same time. The level of heat that is dissipated from the regulator in this application would not make heat sinks necessary. It is, however, always good practice to bolt all TO220 devices to a rigid surface of some kind, rather than installing them as freestanding components. When attaching these packages to blank metal surfaces, it is, however, necessary to electrically insulate them from the housing. In order to do that, insulating lamination is inserted between package and housing. In addition to that, it is necessary to use plastic nuts and bolts or metal bolts with special plastic washers. These specialty components can be salvaged from any old ATX power supply. In addition to these electrical insulating measures, it is recommended to use thermal compound to keep the thermal conductivity high. After the bolts are tightened and the spare compound is wiped off, our work at the power supply and the voltage reference circuit is completed. The only part of the circuit that remains to be built now is the op-amp. If you want to know how the device can be finished and calibrated, please watch part 4 of this series. And please subscribe if you like my videos.